this, f superscript -1 of x. That's just notation. Now, if you were in a middle school and you saw this, don't confuse it, guys. You might think, Professor, it means this. But you did back in middle school. In other words, if you saw 2 raised to a -1, it is 1/2. That's the way it worked back then. Now, though, they use a superscript, not necessarily an exponent. A superscript of -1, just notation. They want you to find the inverse of a function. So guys, this time, I'm going to just give you one function, not two. Just one function and ask you to find the inverse. Find the other one that's missing. I think right before the break, I gave you both of them. Okay, so here, given. Now watch carefully, because I'm going to start with something really, really basic and move into it. Guys, I thought about this, and I thought, hold on, I better show my students this first. Let's call this, let's call it set A. We use ordered pairs. Set A contains these numbers, or ordered pairs. -1, 2, 0, 3. I threw in 1, 4, and 2, 5. Close that up. I'll let that represent a function containing only 4 ordered pairs. Now, I have another function, or set of ordered pairs, B. And B is going to contain these ordered pairs. Just put ease into it. I got -2, 4, 0, 0, 1, 1, 2, 4. Close it up. I have that to look at. Now, they want you to look at these two, or us together, and interchange the coordinates. That's what it comes down to. So I'm going to go to the purple one first, guys, and interchange the x and the y. That's merely all it comes down to find the inverse. You're interchanging the x and the y. They ask you to find the inverse. Okay, we're going to go to the purple one first. Its inverse, if I do that, right like this, a superscript -1. If I go through and interchange, that first ordered pair becomes 2, -1. The next one, if I interchange, becomes 3, 0. Next one becomes 4, 1. And the last one is 5, 2. Close that up. That's going to represent the inverse of A. Just interchange them. Now let's say, okay, let me go down to set B in the green, do the same thing. I'd like to find B's inverse. Which means go through and interchange the ordered pairs and make the green now look like this. Just interchanging the best I can here, guys. This, and accept that for the inverse. Okay, anyone tell me the difference in finding the inverse of the A in the purple, which I did, I interchanged, and the inverse from the B in the green? I want you to focus on, we found the inverse, we interchanged, and we said, okay, Professor, if you give it to me, I'll just go through and interchange the x and the y, and I got that for the inverse, for the purple. The green one, let's do the same thing. If I ask you for the inverse, you say, well, let's do the same thing. Go through and interchange the x and the y. Okay, what's anything going on here when you look at the answer for the purple compared to the answer of the green? Go for it.
Is it the 0, 0 and 1, 1? Are they the same answer?
Okay, beautiful, right here. 0, 0, 1, 1 did not change. I'll take that. Absolutely didn't change. You interchange the coordinates. Go back to the purple. Look at the green. And I'm gonna ask you to zoom in on a key word here. They're talking about inverse functions.
Green is not a function because.
There you go, I'm hearing something, I'm hearing, hold to me again.
The 4 has 2 y values.
Look at that, beautiful, beautiful, beautiful. We did what we're supposed to do, interchange. Isabella, you're telling me now, Professor, hold on. You did the interchange in what you're supposed to do for an inverse. But she says when you interchange on the green one, Professor, you get 4 repeated here. That cannot happen for a function. In other words, the green is not a function. We want an inverse function. So she says, oh, Professor, you can accept this. Not a function. Therefore, what I did in the green, I can't do. There is no inverse. I tried it. The purple one, guys, looks pretty good. I don't see anything repeating there on the inverse. So yes, I'll accept this as the inverse for the purple one. But the green one, Isabel, described that perfectly. She says it's not a function. And that's what it comes down to. You interchange the x and the y, and then find the inverse. And I tried it with some numbers here. Before I leave it, can anyone just out of curiosity tell me, I gave you these ordered pairs. I had something in mind. I didn't just randomly put those numbers in there. I had sort of like a formula or a rule to follow that gave you those numbers. What relationship does one see between the x and the y for each of those 4 ordered pairs? It's the same relationship for all 4.
Increase it by 1.
Let me get it.
Increase it by 1.
Increase, oh yeah, I heard increase by, I think it's increased by 3. If you put a 3 here, if I add 3, you get this, 2. If I add 3 to 0, you get 3. If I add 3 to 1, you get 4. Consistently. If I add 3 to 2, I get a 5. So I'm gonna write that like this, guys. That function can be expressed as x plus 3. Equal right out. The green one. Here's the original green. Does anyone have an idea of what did I have in mind there? What relationship is there for the green one? And I'll write that out as a function.
X times X.
Oh, do it again. X squared?
Yeah.
X times X squared? What's what happened here? I agree. The green one can be expressed as square the X, you get the Y. Square the X, you get the Y, all the way across. This one, though, came out to be not a, I can't do an inverse. This one, I can do an inverse. So there's something going on between this and this. Oh, wait, guys, this is linear. If I graph it, it's linear. Let me graph it real quickly in the purple to point out what's going to happen here. Now, if you want to use the mx plus b form, go for it. I'm going to use the x-intercept, y-intercept real quickly. The x-intercept set this equal to 0, you'll get -3. Replace x by 0, you'll get 3 for the y. And if you connect those two guys, you're going to end up with something like this. And that's representing the graph of the purple. If I graph the green one, which we've seen so many times in this class, x squared really sketches into this. A parabola. Now, can anyone tell me, if you saw the pictures of the graph, of the functions, which I gave you a linear and a quadratic, might you see something when you compare the purple straight line to the green parabola that might tell you, Professor, the green one cannot be done. It has no inverse. What's the difference? What's the difference in the purple straight line and the green parabola? As a graph that may say, Professor, don't deal with it. The green one cannot, we tried it, cannot have an inverse. We tried it. Can you tell me the difference?
If it reflects.
Can I get it?
If it reflects, it's the same.
Not quite. Let me give you a little hint. Are both these graphs of functions? Does the purple graph and the green graph represent functions? And what did we use earlier to determine whether a graph is the graph of a function or not? A vertical line test. Did we? You pass the vertical line anywhere you wish. There's only one point of intersection, either with the green or the purple. Now there's a test called horizontal. Suppose I try a horizontal test, draw a horizontal line. If I draw a horizontal line anywhere I wish, guys, on the purple one, I don't care where you draw it. I'm gonna do it like this. A horizontal line. A horizontal line. No matter where I draw that horizontal line on the purple, how many points of intersection are there? Only one. What happens on the green one? If I draw a horizontal line, how many points of intersection do I get here? 2. If you have more than one point of intersection, that tells you your function, don't mess with it, has no inverse. Okay, so the graph tells you right ahead of time, don't mess with it. If you have 2 points of intersection, don't mess with it, it has no inverse. Okay, guys, so they call this the horizontal line test. We'll put this in here. The horizontal line test. Now, before I jump in and start the work, oh boy, here goes. We saw earlier a graph that looks like this, which is the square root graph. Looks like that, square root x. We see that before. Would that pass the horizontal line test? If I draw a horizontal line anywhere I wish, will that horizontal line intersect my green graph only one time? In other words, here's my horizontal line. Use the horizontal line test. How many points of intersection do I get? 1. Now, could I draw somewhere else and draw somewhere else on another location and get more than 1 point of intersection? No. So this thing has an inverse. It has an inverse. This one, in my description here, so a square root has an inverse. Suppose it looked like this. Which you'll probably see more of that type on the exam on Wednesday. It's a polynomial function. Would that thing pass the horizontal line test? Definitely not. If I draw a horizontal line anywhere I wish, this one has a point of intersection here, has a point of intersection here, has a point of intersection here. Definitely no inverse for it. Should be only 1 point of intersection. Okay, so I got to watch out for that when they ask me to find the inverse. So guys, here we go here with the inverses. Let me go back to the one that worked out. The green one did not work out, so I'm not going to mess with it. The purple one did work out. I named it for you. Can anyone tell me right quickly, this is going to be easy, can anyone name the domain for me, the set of x's for the purple one? For the original function set, I call it set A. What are my x's, my domain for the original function set A? Now, this them right here. What are they? The x's. -1, 0, 1, 2. That's my domain. So I got -1, 0, 1, 2 is my domain for my original set. Its inverse, and which it did have an inverse, we did it. Now let's listen to the domain for it. The domain for it, guys, for the inverse, 2, 3, 4, 5. This is for the inverse. Let's go back up. Now this is the range for the original, the set of y's for the original. Go through the original, the y's are 2, 3, 4, 5. Done. Now suppose we got to go down here and ask you to name the range on the inverse. Now I'm looking at this one. Well, the y values there for the range for the inverse is -1. The y's 0. The y 1, 2. Can anyone give me a summary, a conclusion? did the domain and the range on the original function. Then I found its inverse by interchanging. We got the inverse to be this. And then I asked you for the domain and range on the original, and then also list the domain and range on its inverse, and we haven't listed. Anything going on here? Any relationship? I'll put it right here. What relationship do you see when you look at this? Now guys, keep in mind, this is for the inverse, and this one's for the original. Okay, the domain of the original, we'll call it F, is equal to, Michael, can begin? The range of the inverse written with that superscript. They match up. Now, Michael, since you gave me that, could I also say this? Range of the original corresponds with what? The domain of the inverse. That's always true for inverse functions. That relationship. Are we okay, guys, with that? Some mere looking at some ordered pairs and so forth and so on. Okay, I got a horizontal line test. This will tell you at the very beginning, is it possible? If it doesn't pass the horizontal line test, forget it, it has no inverse. Your textbook says if it does pass the horizontal line test, they describe this as the function must be a one-to-one function in order to have an inverse. The function must be a one-to-one function. Or it does not have an inverse. That's the same as that horizontal line test, guys. Let me go back to the one that did work, or that did not work. The green one did not work. The function must be a one-to-one function. The green one, what messed me up in the original here, Isabella, help me out here. -2 is paired up with 4. At the same time, if there's something else paired up with 4, is also 2 paired with 4. I can't have that, it's not 1-to-1. Up here, the one that did work out, the purple one has an inverse, -1's paired up with 2. Is -1 paired up with anything else? No. 0 is paired up with 3. Did I have 0 paired up with anything else? No. So this is a one-to-one. So if it's one-to-one, it has an inverse. Or if you want to look at the graph, the horizontal line test. And therefore you have an inverse. So guys, that's inverses, but, here we go. I'm gonna make this brief. Then we'll give you 2 functions, or 1 function. Part 2. We'll give you a function. We did some great work tonight. I brought in this one. F of x is equal to this. Here it goes. You have an exam coming up on Wednesday. I thought, why not? Why not tie lessons together? I've got 2x subtract 3 over x plus 4. Whew. I want to find, if possible, I'm going to just use this notation, its inverse. Now notice I did not list ordered pairs for you this time. And if you find the inverse, I want the domain of the inverse. And I want the range of the inverse. That's going to take a little time, but we'll do it. Now, appreciate this. Is the function given here a rational function? You have an exam on Wednesday that may have a rational function. So what I'm going to do, your textbook I don't think did it for you, I'm going to sketch this. Why not tie 2 lessons into 1? So I'm going to go ahead and sketch right quickly what this rational function looks like as a sketch. And guys, you're going to help me out here. I'm going to write down all the steps on this one. But I like to see what the graph looks like. Okay, look at it closely without all the steps. Can anyone tell me where is the x-intercept on this graph that I'm looking for? How do you find an x-intercept for a rational function? You set equal to 0. Is that true? Okay, so if we want to find the x-intercept right quickly, guys, maybe I should be more organized here. The x-intercept really comes down to set your function always equal to 0. I'm going to do a quick cross multiplication, which merely leads me to this, which leads me into 3 halves. So 1 1/2, go right behind the point there, 3 halves, 1 1/2 0 is my x-intercept. So I'm going to place it on the graph right now. So out at 1 1/2, right here, guys, here's my x-intercept on this graph. Y-intercept, easily done, find R of 0. I need to f of x. Replace all the x's by 0, I think you end up with -3/4. I prefer an ordered pair for the y-intercept written like this. Looks much better. The truth. Let me go ahead and plot that, get it out of the way. It's -3/4, and down here it's -1. So right here, call that -3/4. Squeeze that in. There. Got that much. Anyone tell me right quickly, without me write everything down, where's the vertical asymptote located on this particular rational function? -4. Let's go out to -4. Good little practice, and also tying in a new lesson here. We'll start with -4 and show there is a vertical asymptote right here. We got that out of the way. Can someone tell me? Be clever. I will tell you ahead of time, there is a horizontal asymptote on this one. Anyone tell me its location? See, where's the horizontal asymptote to be drawn here? I think I heard it. 2. Absolutely. So let's go up to 2. Follow that horizontal. Let me use a different color for it. The horizontal line, horizontal asymptote is at 2. Here. Now, Brianna, thought about what you asked earlier. Got this. If it has a horizontal asymptote especially, there might be a crossover point. So how does one find the crossover point? If there is one, we set the function equal to 2 in this case. On the side here, so I'm gonna take my function. Guys, I'm not as organized on this one as I usually am. It says equal to 2, and try to solve that. I'll tell you ahead of time to save myself a little time. We do cross multiplication, whatever you want to do there. The 2 x's will cancel. There's no x. So there's no crossover point. Because that just saves me a little time there. So there's no crossover point here to worry about. I've got the horizontal, I've got the vertical. There's no oblique. You can't have oblique and horizontal at the same time. I've got my intercept staring at me. There's no hole on the graph. That should be enough to graph it. So since I have only one vertical asymptote, there's only 2 pieces, something to the left, something to the right. By the way, on Wednesday's test, if you should have 2 vertical asymptotes, how many pieces to the graph should there be? 3, to the left, right, and in between. This one has something going on here, and I think most students say, Professor, it's gotta look something like this. It's gotta follow those asymptotes. Pick up the intercepts. Is that true, guys? On the other side, I have, it's vacant, there's nothing there, but I think it's gotta look like that. It's gotta follow those asymptotes and be there. That's true, guys? Got it. There's a graph. Does that graph pass the horizontal line test? If I draw a horizontal line anywhere I wish, will there be only one point of intersection? If so, this thing has an inverse. It passes the horizontal line test, therefore I can find this, it doesn't exist, I need to find it. You guys, with all this said, oh, before I leave, my goodness. Can anyone tell me the domain? That's the graph. Based on the graph, what would you say the domain is? X cannot be, what, -4? I think we said X could be a -4 earlier. And the graph is saying the same thing. By the way, if you want to write like this, go for it. Saying the same thing. X cannot be a -4. Range, the up and down, gotta be careful. Anyone tell me the range, since I have the graph, what's the range, the up and down? I notice it's dropping down forever. Now what? -infinity up to what? 2. It'll never touch 2, up to 2. It jumps across 2 out here and goes through infinity. There's my range. So far, so good? Okay. Now, the question is, oh yeah, Professor, you did all this business, but you didn't answer the question yet. The question is, find the inverse. You haven't found the inverse yet. But just find the inverse. Guys, only 2 steps to find the inverse. Step 1, interchange the x and the y. Go back to one function they give you and interchange the x and the y. Now go back to my functions here, I'm gonna rewrite it like this. X is equal to 2y subtract 3 over y plus 4. Just interchange them. And then second step of the 2-step plan, only 2 steps, solve for y, get the y completely by itself. And you'll be finished. That will be the inverse. I would suggest to get the y by itself here, guys, to clean this up. I'm gonna do a quick cross multiplication. I don't want to throw anyone off here, but I'm gonna do it like this. Now watch carefully. I did a quick cross multiplication. And I did it quickly, and I did it quickly. It looks like that. Now I'm trying to solve for y. I see a couple of terms that have the y in it. I need to get those terms together, so I need to move that 2y over to join the other term that has the y. Bring them together, back up within a grouping, they're together now. Move that 4x over to the other side, it does not have a y. Just move some terms around. Now what am I going to do with those 2 terms that contain the y? Take the y out as a common factor. You got this. Now what's my last step if they say solve for y? Get the y by itself. Only one more step. What would you do? You get the y completely by itself. Divide through by what? X minus 2. These cancel. So guys, the result is I got y completely by itself, which we want. And we got a strange answer. We have it to look like this. And to make a stronger statement, this is my inverse. I finally found it. If I have no mistake. Whew. So it says find it, I found it. Now they want its domain and its range. Now can anyone look at this right here? I've got a little graph on the side also that's going to help me. But if you just look at the inverse itself, which is right here, what would you say the domain is? What can x not be? X cannot be what? 2. Is that true? Range might be a stretch. Does anyone think they know what the range is for that inverse? Now let's see the connection. Finish it up. I think I see some heads nodding like, Professor, I see what's going on here. Was this the domain, the range of the original function? Did we say those were being interchanged here? So if I want the domain, the range on the inverse, this is the inverse, guys. The domain on the inverse, I'll put it right here, should be equivalent to, Michael said earlier, the range of the original. Professor, if you want the range of the inverse, which I do, it should be the same as the domain of the original. They interchanged. So we got this one out of the way here. Now the range, if I can't see it right here in my answer, the range should correspond with the domain of the other one. And what was the domain of the other one? X cannot be what? Was it -4? I got to put a y there for range. Y cannot be -4. Or you put in integral notation if you wish. Jeez. Is that making sense? They interchange X and Y, the domain and the range are interchanging, and we got all that done. Now, the question was, find the inverse, we found it. Professor, where is it? Right here. Domain of the inverse, finally, we found it, we said X cannot be 2. Range of the inverse, we could not quite see at first, just looking at this, what the range was. The connection here was that range should be the same as, where was it? The domain of the original. So you may want to go back to the original and find its domain. And that should correspond with the range of this one that was more difficult to find. Do we have everything done then? Now, I'm watching my time here. So we did a beautiful job tonight. Now, last step. I hope we didn't make a mistake. You know how algebra is, sometimes you make a mistake, you put a plus sign when you should have been a minus sign, or something happens. I could have done that here. I'm saying, I think the inverse is this. You said, Professor, is there a way to check it? Before I turn my paper in? Of course, this is not on the exam on Wednesday, but the next quiz, maybe next Wednesday, is there a way that maybe I can put a positive sign there rather than a negative sign, made a little simple mistake? Is there a way to check it? There is. Before I show the official way. Can anyone tell me, let's think about what inverse means. Can anyone tell me, or give to me, some ordered pair belonging to the original function? An X and a Y, and I don't care what you give me, that belongs to the original function.
Zero and -3.
I heard 0, replace X by 0, and negative Brianna 3/4. In fact, I think we found that true on the graph also, right? What should the inverse do to her ordered pair? We think the inverse is this. But the inverse, if this is true of the inverse, it should turn that around. In other words, interchange her answer up there. So wait, Professor, your inverse down here had better satisfy this. Now let's see if it does. I'm going to replace X by -3/4. I'm going through a lot of business tonight. Okay, X by -3/4 in my inverse. Subtract 3. Denominator, X subtract 2 would be a -3/4. Subtract 2. Make sure you follow me here, guys. This product out front is positive, 4 is canceled, so +3. Is that +3 out front? Right here? And then 3 subtract 3 on top gives you what? 0. I don't care what this is down here, the answer's gonna be 0. Yes or no? So is that what I wanted? Did it check? Now, before I show you the official check, we can stand here all day and try some. Can someone give me another ordered pair belonging to this function besides Brianna's 0, -3/4? And give me something interesting. A little bit more demanding. I'm glad you started me out with 0 and -3/4 still. Give me something else. Replace X by any number you wish. And tell me what the Y is, the answer, and I'll use that. Anyone come up with something? Maybe a 5, maybe a 6, -2. I don't care what you give me. Anyone got one? I've been bragging on you guys. Anna, hard. Next time I start bragging on this class, stop me. Give me one more ordered pair.
5 and 7 over 9.
Okay, if I put a 5 in there, 5 would be on here 7, 10 subtract 3, over what, 9? Okay, I'll try that. Abigail, is that you?
Yes.
5, and help me out here, you said 7 over 9. Okay, let's try it. Professor, that belongs to the original function. Now, if I turn it around, interchange it, and say, hold on, I'll take Abigail's answer and put 7 over 9 for the X and 5 for the Y. Now, this does not satisfy this, we're in trouble. She gave me an awkward number to work with, but we'll do it. Abigail, here goes. In my inverse, I got -4. She gave me 7/9. Subtract 3. all over, where am I? 7/9, subtract 2. Make sure I put all that in there correctly, guys. I put the 7/9 for the x into that. I'm hoping, Abigail, when I clean that mess up there, it's fine. I'm hoping. We gotta clean this up, guys, with a common denominator. Let's see. Out front here is a negative, what is 4 times 7? 28? That's a negative 28 over 9. Oh, I guess I need a common denominator of 9. That 3 hanging on the end. Can someone express that in terms of a 9 for a common denominator? And still have 3? Still have 3 on the end, but with a 9. 27 divided by 9, nice. That's 3. Down here, I got 7/9. Can you do the same thing for me down here? Can you change that 2? Still have 2, but with a common denominator of 9. 18 over 9. Now, if I clean that up on top, I get negative, what is 28 and 27? I'm getting scared. Is that 55? Negative 55? On top. Over 9. Got me scared. Down here, 7 subtract 18. Negative 11 over 9. You know and I know, those will cancel. And we're going to the 5. It worked. Now, I didn't do a count today. I don't know how many students are here. I think all my students are here today. If I ask from the very beginning all the way around for every student here today to give me a different ordered pair for each student, and then I had the time to flip it around, interchange it, and check it, it should check. Now, can we do that? No. When they say it should work for all numbers, are we able to test all numbers? No, there's an infinite number of these. So, Professor, how can I do it more quickly than using numbers like Abigail gave you, which I love, it checked. I'm doing this, Brianna gave me this one, it checked. But there's others that would check. And we don't have the time to list all those, there's an infinite number of them. Now here's the official check. You have found the correct inverse if this happens. If on the side, now I'm sort of slowing down this, guys. This ties into the lesson here. If you take your function and form a composite with what you think the inverse is, with respect to x, and you get x, like you saw earlier before the break. That says without testing numbers, like 4/9 and all those numbers are given to me, without going through all that, Professor, check that. If that comes up to be a true statement, that says, oh, you have found the right answer. Now, what does this mean? It means find f of the inverse. On the left-hand side. Now, we'll do that. Inverse. We think the inverse on this one was, we're at, oh, this strange thing here. Is this the one? That's the inverse? Okay, it's negative 4x subtract 3. Oh, negative 4x subtract 3. And that's over, I'm being patient, I'm closing down with this, guys. Over x subtract 2. And I've got to take f of that. Oh, I guess I'm getting scared here at the end of class. Now, what does f of that inverse mean to do? Now go back to your original function, if I can find it in all this mess. Oh my, what's this, the original function? Then I've got to go back and replace, here we go, this 2 times, and right here in place of x, put the inverse, negative 4x subtract 3, oh, I'm really getting scared, over x subtract 2, subtract 3 back there, and it's supposed to be over, go back to f, x plus 4 looks like this, negative 4x subtract 3 over x subtract 2, so be patient, plus 4. Now, I'm hoping, you're hoping. Professor, if this mess, it's a mess. If this mess, when I simplify it, Professor, comes out to be merely X, I feel that answer's correct for sure. Guys, let's clean this up. Here we go. I'm gonna multiply through by 2 here, make that negative 8x. Be very careful here. Negative 8x, subtract 6. Still over that common denominator. So that's cleaned up there, just clean it up. I've got a 3 here. Anyone tell me how to express 3, still have 3, but with a common denominator of x minus 2? Still have 3 though. Anyone tell me what you might want to do here on the end? It's minus. Still have 3, but have it with a common denominator of x minus 2. Be clever. What could you do? All right, mine like this. 3 times x minus 2 over x minus 2. Please tell me, is that still 3? Now they both have the same denominator. I'll come back and clean that up further. The bottom part. Down here I got negative 4x minus 3. Oh, I am really getting scared. That over this. Now, can anyone tell me what that 4 looks like down there over that same denominator? I still have 4. Anyone have an idea? Did I write like 4 times x minus 2 over x minus 2? Please tell me. Same denominator. Is that still 4? Right? Okay. Here we go. Brianna, this is a mess. I'm running out of time. Well, am I ever? Right now, even as an instructor, I've done it for years. If you said, Professor Ramsey, this is merely X, and you cleaned up, I would doubt it. I'm hoping it's X. If it is, we've answered the question. Okay, here goes, guys. Okay, cleaned up. Okay, we'll close this down. This is negative 8x, subtract 6. This part, be very careful with. That becomes the negative 3x plus 6. All over that common denominator. There's the top part. I hope I did not make a mistake there. Let's hope I did not, and I don't think I did. Okay. Now the bottom part, negative 4x minus 3. Here becomes 4x minus 8. Oh boy. All that's over x minus 2. That's the bottom part if I have no mistake. Let's hope I don't. Clean up further, go back to the top, guys. 6's will cancel. That's a negative 11x over common denominator. Down here, clean this up. I think the 4x's cancel. Negative 3, negative 8, that's a negative 11 down there over that. Is that true? Whew! And you know and I know these will eventually cancel. And I'm going to end up with a positive, a negative, or a negative. Will the 11s also cancel? Am I left with x? Now, can you imagine on the quiz next Wednesday? I may just give you one of these to 5. And you crunch through, and you crunch through, and you crunch through, you think you did everything perfectly. You say, Professor, I think I have the answer. And you start checking, and you don't get X. You don't get X, and you start getting nervous. You're like, I made a mistake somewhere, I don't have the correct inverse, or I made a mistake in my checking. That's when you start getting nervous if you don't get X. Okay, guys, any concerns here? Take a function, find its inverse, so forth and so on. See, my time is about to run out here, guys. By the way, did we graph this one? We did, didn't we? It was here, wasn't it? Is this the same problem? This is a sketch of the original function. Now, you know what they're going to ask us to do next? Not tonight. What do you think they're going to ask me to do next? Sketch the inverse. Sketch this. Where is it? My goodness, where's my inverse? I'm all lost here now. We checked it and the inverse came out to be this, didn't it? Now, by the way, can you tell, I'm not gonna sketch it. Can you tell me, if you were to sketch before we close down, where's my vertical asymptote located? Just vertical asymptote, out of curiosity, for the inverse if I were to graph it. 2. Look back at the original where I graphed the original function, I just invert. Where was the horizontal asymptote located on it, the original? Was the horizontal up here at 2? Does that correspond with when you interchange the vertical for the other one? Everything's been turned around. All right, quickly, can anyone tell me, what's the x-intercept on the inverse? Let's do the y first, no, close down. What's the y-intercept on the inverse if you replace the x's by 0? Right here, this is the inverse. 3/2, 3 halves. So I got 0, 3 halves. If I turn that around, that should be the x-intercept on the other one. Was that the x-intercept? Where was it? 1/1/2 on the other one. Everything's been turned around from one function to the other. If not, you have found the wrong inverse. Okay, guys, your exam. Here's my concern. You have the section numbers. We go back to chapter, oh my goodness, help me out here, guys, 2.8, was it? I think this has some value. We test on it again. Then you got all of chapter 3. So it's 2.8 and all of chapter 3. All this new stuff? No, not on this exam. Now, what am I most worried about? I think you most worried about of all those topics? I don't think it's polynomial functions, graphing, increasing, decreasing, cross-touch, all that in behavior business. I think we can all do that. To find the zeros of a polynomial function, you had one of those on the last quiz. Now that could be demanding, but this is P over Q, you're gonna have that again. What bothers me though, in chapter 3, oh, I better erase them. No, I don't. One of these. Oblique asymptote, horizontal asymptote, crossover points, that, and this, and that, and this. That's the only part, I think, that you'll have real difficulty with, is grabbing one of these rational functions. So guys, be ready for me? And I'll be here on, Wednesday at 4 o'clock. Okay. If anyone wants to stay a little late tonight, a few minutes late, I'll be